Welcome to a journey through Earth's hidden mysteries. Tonight, we'll explore together an invisible realm that sustains all life around us, but which we rarely pause to contemplate. Prepare to discover the secrets of the most ancient and fundamental beings on our planet. To begin this exploration, I invite you to close your eyes for a moment and imagine. Imagine that you can shrink to the size of an ant and dive into the soil beneath your feet. There, in the silent darkness of the earth, exists this entire world you've never seen, a realm that works tirelessly while you sleep, work, or dream. This is the kingdom of fungi, the invisible guardians of life on Earth. Have you ever wondered why, when a leaf falls in autumn, it doesn't remain there forever? Why aren't forests cluttered with dead branches and fallen trunks accumulated over millions of years? The answer is whispering right beneath our feet, in a network of life so complex and vital that without it, our planet would be unrecognizable. Fungi are nature's alchemists, silent transformers that convert death into life, endings into new beginnings. They are the invisible threads that weave the tapestry of existence, connecting not just plants and trees, but the entire cycle of terrestrial life. And tonight, we'll explore together this fascinating and mysterious universe. Take a deep breath. Feel the air entering your lungs. Did you know that every breath you take is possible, in part, thanks to the tireless work of fungi? They purify the air, renew the soil, and sustain the plants that provide us with oxygen. You are literally breathing the result of these extraordinary beings' work. Imagine for a moment that you're walking barefoot in a tropical forest. Feel the warm humidity of the air caressing your skin, the rich, earthy aroma rising from the forest floor. Under your bare feet, the soil is soft like a natural carpet, full of decomposing leaves, fallen branches, and countless microscopic life forms. What you can't see, but what's happening every second, is one of nature's most complex and beautiful symphonies. At this moment, millions of fungal filaments, finer than human hairs, are extending through the soil, connecting tree roots that may be hundreds of meters apart. They're exchanging chemical messages, sharing nutrients, alerting about dangers, and coordinating the forest's defenses. It's like a biological internet that has operated for hundreds of millions of years, long before our species even existed. Have you ever thought about this? That there's a form of communication as sophisticated as our own internet happening right beneath our feet? Fungi created Earth's first worldwide communication network, and it still works perfectly. 24 hours a day, 365 days a year, without needing electricity, cables, or human maintenance. Now, open your eyes again and look around you. If you're indoors, observe the plants you might have in pots or in the garden. If you're outdoors, look at the trees, the grass, any vegetation within reach. Each of these plants is connected to an underground network of fungi. They're not alone, they never have been. They're part of an invisible community that extends for kilometers in all directions. This revelation has fundamentally changed our understanding of nature. For centuries, we saw forests as collections of individual trees competing for sunlight, water, and nutrients. But reality is much more beautiful and complex. A forest isn't a crowd of individuals, but an integrated superorganism, where each tree is like a cell in a larger body, connected through fungal networks that form the forest's nervous system. Close your eyes again, and let's dive deeper into this underground world. Imagine you possess special vision, capable of seeing through the earth as if it were transparent. What you would see would be breathtaking, an infinite network of delicate filaments, finer than human hairs, extending in all directions like a gigantic three-dimensional web. These are the mycelia, the true bodies of fungi. What we see on the surface, a mushroom here, another there, are merely the reproductive structures of fungi, equivalent to a plant's flowers. The real organism is underground, spread through a network of filaments that can extend for kilometers. To understand the scale of this network, imagine you're flying over a large city at night. You see the lights of houses, buildings, streets, all connected by an intricate network of roads, power cables, and pipelines. Now imagine that this city extends not just horizontally but also vertically, with connections flowing through multiple underground layers. This is a close analogy to the complexity of the mycelial network that exists beneath your feet. Have you ever thought about what it truly means to be connected? Fungi teach us a profound lesson about interconnection that our modern society, often fragmented and isolated, desperately needs to learn. They don't exist as isolated individuals fighting for survival, but as part of a vast and generous community where one's success contributes to everyone's success. Each mycelial filament extending through the soil is like an outstretched helping hand, a communication thread, a bridge between worlds. These filaments can detect and respond to hundreds of different chemical signals, distinguishing between different plant species, identifying specific needs, and even recognizing familiar plants that are genetically related. Imagine for a moment that you're a young tree, newly sprouted in a dense, competitive forest. Your roots are small, still inexperienced in extracting nutrients from rocky, poor soil. Sunlight barely manages to penetrate the closed canopy above you, limiting your ability to photosynthesize. How would you survive in this challenging environment? This is where fungi enter as generous and wise mentors. They envelop your delicate roots with their filaments, creating a symbiotic partnership that will last your entire life. This intimate union, called mycorrhiza, which literally means fungus root, is one of Earth's oldest, most successful and fundamental symbioses. The fungus offers the young plant a dramatic extension of its root system. While the plant's roots might extend only a few meters, fungal filaments can reach resources hundreds of meters away. It's as if the young plant suddenly gained arms that could reach much farther than it ever could alone. Through this network, the fungus provides the plant not only with water, but also essential mineral nutrients like phosphorus, nitrogen, potassium, and a variety of micronutrients that its roots could never reach or absorb efficiently. In return, the plant shares with the fungus the precious sugars it produces through photosynthesis, an energy currency that the fungus, living in the darkness of the soil, cannot produce on its own. But this partnership goes far beyond simple commercial exchange of resources. It's a deeply integrated collaboration where each partner becomes stronger and more resilient through the other's presence. Plants with mycorrhizal fungi grow faster, are more resistant to diseases, more tolerant to drought and stress, and can survive in soils that would be toxic to non-associated plants. What if I told you that long before we invented the internet, nature had already created its own worldwide communication network? The Wood Wide Web, as scientists affectionately call it, is an information and communication system that would make our brightest software engineers green with envy. Imagine yourself walking through an ancient forest, say a redwood forest in California, where colossal thousand-year-old trees rise like living cathedrals. What you see are majestic individuals, each tree apparently independent of the others, silently competing for sunlight and space. But if you could look through your magical ant eyes, you'd see that these trees are constantly conversing with each other through an underground communication network more sophisticated than any human system. This communication happens through chemical signals that flow through the mycelial network. When a tree is attacked by insects or pathogens, it doesn't suffer in silence like a solitary hero. Instead, it immediately sends alarm signals through the fungal network. Attention! We're under attack. Prepare your defenses. Trees that receive this urgent message immediately begin producing specific defensive, chemical compounds for the type of threat identified. It's like a military early warning system, where intelligence information is instantly shared among all units, allowing for a coordinated and effective response. Have you ever felt truly alone? Trees never experience this loneliness because they live in a constant community of communication and mutual support. A forest isn't a gladiator arena where individuals fight to the death, but a cooperative society where individual well-being is intrinsically linked to collective well-being. But the Wood Wide Web is even more sophisticated than a simple alert system. It allows trees to share resources dynamically based on momentary needs. During prolonged drought, trees with access to underground water sources can share this precious water with neighbors who are suffering. It's like a socialized forest healthcare system where resources are redistributed based on real need, not payment capacity. In autumn, when deciduous trees are losing their leaves and their photosynthesis capacity dramatically decreases, evergreen trees can literally feed their temporarily vulnerable neighbors, sending sugars through the fungal network. It's an act of generosity that ensures the entire forest survives the harsh winter. Perhaps even more remarkable is the ability of mother trees, ancient and experienced trees, to nurture and protect their offspring. Through the mycelial network, a mother tree can identify her own genetic daughters and provide them with extra nutrients, especially during their vulnerable early years of growth. It's like a loving mother extending a spoonful of nutritious soup to a hungry child, but happening through invisible underground chemical connections. This discovery revolutionized our fundamental understanding of nature. For centuries, our scientific view of life was dominated by the Darwinian concept of survival of the fittest, interpreted in a limited way as ruthless competition between individuals. But fungi revealed a deeper and more complex truth. Life thrives through sophisticated cooperation. Think about your own life for a moment. How many times have you achieved something truly significant completely alone? Probably, like forest trees, you've depended on a complex network of relationships. Family who offered emotional support, teachers who shared knowledge, friends who gave encouragement, colleagues who collaborated on projects. Fungi remind us that interdependence isn't a weakness to be overcome, but the very essence and strength of life. Now, let me take you to a place you might prefer to avoid in thought. A natural cemetery of leaves on the forest floor, where fallen trunks slowly rot and dead vegetation accumulates in layers. There, among the time-yellowed leaves and moss-covered branches, happens one of Earth's most important and fundamental magics. It's the theater of decomposition, where fungi play the leading role in this essential drama of renewal. Have you ever seriously contemplated what would happen if nothing in nature decomposed? Try to imagine a world where every fallen leaf, every broken branch, every dead animal remained exactly where it stopped, preserved forever like a natural mummy. Forests would quickly suffocate under billions of years of accumulated debris, piled in ever higher layers until no sunlight could reach the soil. Earth's surface would be a vast cemetery where nothing new could grow. Fungi are nature's great cosmic recyclers, mysterious alchemists who possess the almost magical power to transform death into life, endings into new beginnings, waste into treasure. They possess an arsenal of specialized enzymes, like unique and precise chemical keys, capable of opening the most complex molecular locks of dead wood, fallen leaves, decomposed animal bodies. When a fungus encounters a fallen trunk from a centuries-old tree, it doesn't see obstacle, problem, or dirt. It sees a vast library of nutrients waiting to be carefully cataloged, read, and redistributed to nourish new generations of life. Its delicate filaments penetrate the hard wood like experienced librarian fingers leafing through ancient pages, patiently extracting carbon, nitrogen, phosphorus, potassium, and dozens of other essential elements that were trapped in the dead tree's structure. This extraordinary process is not merely destructive, but profoundly creative and regenerative. It's like watching a visionary artist who takes used and faded colors from an old painting and transforms them into a completely new and vibrant masterpiece. The precious nutrients released by fungi during decomposition fertilize the surrounding soil, feed new young plants, and sustain the entire intricate food chain that depends on this constant renewal. Without this tireless and meticulous recycling performed by fungi, life on Earth would literally have stopped billions of years ago, suffocated by its own productivity. Every carbon atom in your body has been part of distant stars, ancestral plants, animals extinct long ago, and countless other life forms that existed throughout cosmic history. Fungi are the universal librarians who keep this perpetual circulation of elements running smoothly, ensuring that nothing valuable is lost forever. There's a profound poetry in this process when you really stop to contemplate it. The majestic tree that provided shade and oxygen for decades, when it finally falls, doesn't simply disappear. Through the patient and reverent work of fungi, it gradually transforms into rich soil that will nurture the next generation of trees. It's a cycle of generosity that perpetuates through eons, where each death becomes the foundation for new life. Have you ever thought that every breath you take contains atoms that were once part of dinosaurs, carboniferous forests, primitive oceans? This perspective connects us deeply with all of Earth's life history, and fungi are the silent facilitators of this ancestral connection. Let's now go to a laboratory in London in the year 1928. A Scottish scientist named Alexander Fleming returns from his summer vacation to find something completely unexpected. In one of his bacterial cultures he had left on the bench, a common mold, a simple blue-green fungus, had accidentally contaminated his carefully prepared experiment. Any other researcher would probably have thrown everything away, irritated and frustrated with the accident that ruined weeks of meticulous work. But Fleming was a naturally curious man, with eyes trained to observe the unusual. He noticed something absolutely extraordinary. Around the mold colony, in a perfect circle, all the dangerous bacteria had simply disappeared. That apparently common fungus of the genus penicillin was producing a mysterious substance that killed pathogenic bacteria with surgical efficiency. This casual and almost accidental discovery would become penicillin, history's first true antibiotic, eventually saving tens of millions of human lives. But did you know this wasn't really an accidental laboratory discovery, but rather the scientific revelation of a silent chemical war that constantly happens in soil for hundreds of millions of years? Fungi are perpetually competing with bacteria, viruses, and other microorganisms for limited resources, territory, and survival opportunities. Over inconceivable evolutionary eras, they developed a sophisticated and diversified pharmacological arsenal to defend against invaders and competitors. Fungi are essentially walking natural pharmacies, living biochemical laboratories that produce literally hundreds of unique bioactive compounds, powerful antibiotics, specific antivirals, complex immunomodulators, promising anti-cancer agents, neuroprotectors, natural anti-inflammatories. Many of the life-saving medications in hospitals around the world today are derived directly from fungi or inspired by their ingenious chemical creations. Imagine the incredible medical possibilities we haven't yet discovered hidden in the fungal kingdom. Conservative scientists estimate that we know and have cataloged only about 5% of all fungal species that actually exist on Earth. This means there are potentially millions of species still completely unknown to science, each one possibly carrying the molecular key to cure diseases we today consider incurable or fatal. Have you ever wondered if the cure for cancer, for Alzheimer's, for autoimmune diseases, or for future pandemics might be literally growing under our feet right now? Fungi have billions of years of accumulated experience in solving extremely complex chemical and biological problems. They are incomparable masters of organic chemistry, molecular engineers with pharmacological wisdom accumulated since the dawn of multicellular life. In traditional Chinese medicine, which has thousands of years of careful empirical observation, fungi like reishi, Ganoderma lucidum, are reverently called mushrooms of immortality or spiritual herbs of immortality. Not because they grant literal eternal life, but because they promote exceptional longevity, sustained vitality, and disease resistance. Today, rigorous modern science is systematically confirming many of these ancestral medicinal wisdoms, discovering that certain fungi can dramatically strengthen the immune system, effectively combat various types of cancer, protect the brain against neurodegenerative diseases, and even slow cellular aging processes. The cordyceps fungus, for example, has been used in Tibetan medicine for over 1,000 years to increase energy and endurance. Modern research has discovered that it really improves oxygen utilization at the cellular level and can dramatically increase athletic performance. Turkey tail, Trametes versicolor, contains compounds that stimulate the immune system in ways so specific and effective that they're being used as complementary cancer treatment in several countries. Take another deep breath and imagine that you're walking barefoot on rich, fertile soil of a virgin prairie. Feel the soft, spongy earth between your toes, the fresh moisture rising from the soil after a gentle rain, the earthy aroma of life that seems to emanate from the very earth. You're stepping on one of fungi's most precious and fundamental creations, living, breathing soil. Soil isn't just dead dirt, as many modern urban people imagine. It's one of the planet's most complex, dynamic, and vibrant ecosystems, as intricate and interconnected as a modern metropolis or tropical rainforest. and fungi are its principal architects, engineers, builders, and tireless maintainers. In a single handful of healthy soil, just a teaspoon, there are more living organisms than people on planet Earth. Billions of bacteria, millions of fungi, hundreds of thousands of protozoa, tens of thousands of nematodes, mites, springtails, and hundreds of other microscopic life forms work together in an ecological symphony of cooperation and interdependence. Fungal filaments, the delicate but persistent mycelia, act like natural biological glue, patiently binding particles of sand, silt, and clay into stable and durable aggregates. Imagine billions of small working hands functioning tirelessly 24 hours a day, mixing inorganic minerals, decomposing organic matter, vital air, and pure water in the perfect recipe to sustain abundant life. Without this fundamental fungal architecture, soil would be just loose, sterile dust, completely unable to retain water, nutrients, or sustain any form of plant life. Have you ever observed how rainwater easily and quickly penetrates natural forest soil, but simply runs off the surface of compacted earth or urban pavement? Fungi create a complex three-dimensional network of microscopic tunnels, air chambers, and drainage channels that allow water and oxygen to circulate freely through the soil. It's as if they were hydraulic engineers and ventilation specialists, building an integrated plumbing and air conditioning system for the living earth. But fungi's extraordinary contribution to soil formation and maintenance goes far beyond physical structure. They are true gourmet chefs of the soil, constantly preparing perfectly balanced, nutritious dishes to feed plants of all species. When they decompose complex organic matter, they don't just release raw nutrients, but carefully transform them into specific chemical forms that plants can easily absorb and utilize. It's as if they pre-digest and process all the food, making it more accessible, digestible, and nutritious for their plant partners. Think about modern industrial agriculture for a moment. Why do we need massive amounts of synthetic chemical fertilizers to keep commercial crops apparently healthy? Often, it's because we inadvertently destroyed the complex network of beneficial fungi through excessive and indiscriminate use of pesticides, fungicides, herbicides, and intensive agricultural practices that ignore soil biology. It's like firing all the nutritionists, cooks, and nurses from a hospital and then wondering why patients aren't recovering properly. Healthy soil, rich in diverse fungi, is like a living organism that breathes. During the day, it absorbs carbon dioxide from the atmosphere. During the night, when microbial activity increases, it releases this carbon back to feed plants. This respiratory rhythm of soil is one of the fundamental processes that maintains our planet's atmospheric balance. Let's now dramatically elevate our perspective. Imagine you're floating serenely in outer space, observing our blue-green planet spinning majestically in its solar orbit. You can see masses of white clouds forming and moving in hypnotic patterns, the vast oceans shining like liquid sapphires under the golden sunlight, the green masses of forests and grasslands extending across entire continents. What you can't see from this cosmic distance, but what's constantly happening in trillions of microscopic interactions, is fungi's absolutely crucial role in the delicate regulation of our planet's climate. They're like invisible natural thermostats, working silently to maintain the complex thermal balance that makes Earth habitable for all life forms we know. In forests worldwide, fungi contribute significantly to the formation of condensation nuclei, tiny, microscopic particles around which water droplets cluster to form clouds. When fungal spores are released into the atmosphere by the trillions, they provide these essential seeds for cloud formation. More clouds means greater reflection of solar radiation back to space, effectively helping to cool the planet through a natural climate control mechanism. Have you ever wondered why the air inside a forest always seems fresher, more humid, and more revitalizing than air in urban or agricultural areas? Fungi, working in intimate symbiotic partnership with trees and other plants, create special microclimates that moderate local temperatures. They help trees retain more water in their tissues, which is then gradually released into the atmosphere through the natural process of transpiration. It's as if each intact forest were a gigantic organic air conditioning system, regulating temperature and humidity more efficiently than any human technology. But perhaps fungi's most important and impactful role in global climate regulation is their extraordinary capacity to sequester and store atmospheric carbon. When they decompose organic matter in soil, they don't just release vital nutrients for plants, they also capture and store impressive amounts of carbon in deep soil, effectively removing it from the atmosphere for decades or even centuries. Some conservative climate scientists estimate that world soils contain more stored carbon than all of Earth's atmosphere and all surface vegetation combined. This is a surprising discovery that has revolutionized our understanding of global carbon cycles. Mycorrhizal fungi are particularly efficient in this carbon sequestration process. They can transfer carbon directly from photosynthesizing plants to deep soil layers, where it remains safely stored away from the atmosphere for very long periods. It's as if fungi operate massive underground carbon banks, carefully guarding this fundamental element away from the atmosphere where, in excess, it contributes to global warming. When a tree performs photosynthesis, capturing CO2 from the atmosphere, a significant portion of that carbon is eventually transferred to its fungal partners, who deposit it in stable underground structures. This means that when we destroy fungal communities through chemical pollution, deforestation, urbanization, or inadequate agricultural practices, we're not just harming soil life, we're inadvertently sabotaging one of the most important and effective natural systems for combating anthropogenic climate change. Fungi also regulate climate through their influence on hydrological cycles. Forests with healthy fungal networks retain much more water during rainy periods and release it gradually during dry periods, moderating both floods and droughts. It's a natural flood control and irrigation system that has worked perfectly for millions of years. Let me now take you on an extraordinary journey through the depths of geological time. Imagine you possess a magical time machine and can travel 400 million years into the past, to an era called the Devonian. The Earth you would find would be almost unrecognizable, a predominantly rocky and sterile planet, with vast blue oceans but without a single green plant visible on any continent. The first life forms had evolved in the safe and nutritious oceans, but the continents remained hostile, arid, and seemingly impossible to colonize. But look more carefully. On the rocky shores of primitive oceans where waves meet bare land, something absolutely extraordinary is happening. Courageous pioneer fungi, true pathfinders of terrestrial life, are accomplishing the impossible. They are literally transforming solid rock into fertile soil. How do they manage to perform this apparently impossible alchemy? Fungi produce complex cocktails of powerful organic acids that can gradually dissolve rocky minerals. They patiently settle into microscopic rock fissures and begin their meticulous and persistent work, secreting enzymes that break ancient chemical bonds, releasing essential minerals, creating the first precious particles of true soil. It's like watching invisible and tireless sculptors transforming entire mountains into fertile gardens, grain by grain, molecule by molecule. Have you ever deeply thought about what it means to be a true pioneer? Fungi were literally the first living beings to courageously venture onto dry land, long before plants, animals, or any other complex multicellular life forms. They were the visionary pathfinders who patiently prepared the way for absolutely all the rest of terrestrial life we know today. When the first timid and hesitant aquatic plants finally tried to cautiously venture onto dry land, it was fungi who extended them a saving hand. Literally, the first primitive terrestrial plants didn't possess developed true roots. They depended completely on their symbiotic, fungal partners to absorb vital water and mineral nutrients from the still young soil. It was a desperate partnership of mutual survival, a fundamental alliance that allowed life to finally conquer the sterile continents. This ancestral symbiotic partnership was so dramatically successful that it endures and thrives today, 400 million years later. More than 90% of all plants on modern Earth still maintain intimate symbiotic relationships with mycorrhizal fungi. It's one of the oldest, most enduring, and successful partnerships in life's entire history, a happy evolutionary marriage that has lasted hundreds of millions of years without signs of breakdown. Imagine for a moment the profound implications of this story. If fungi hadn't made this courageous evolutionary decision to leave the safe comfort of nutritious oceans, our Earth would still be an arid and dead planet without majestic forests, without colorful flowers. Without the rich, explosive diversity of terrestrial life we know and love, we humans would probably never have evolved. The very possibility of consciousness, art, music, poetry, science, all of this depends fundamentally on the courageous decision fungi made 400 million years ago. The oldest fossils of terrestrial fungi show structures surprisingly similar to modern fungi, suggesting they found evolutionary formulas, so effective that they remained essentially unchanged for hundreds of millions of years. It's as if they had solved the fundamental problems of terrestrial life early on and never needed dramatic updates. During the Carboniferous period, approximately 300 million years ago, fungi were fundamental in creating the vast forests of giant ferns and primitive plants that eventually transformed into the coal deposits that fueled humanity's industrial revolution. They recycled biomass on massive scales, creating the rich soils that sustained ecosystems of unprecedented complexity. But perhaps even more fascinating is how fungi navigated through multiple mass extinctions that devastated other life forms. They survived the asteroid impact that eliminated dinosaurs, drastic climate changes, ice ages, and all other planetary cataclysms of the last 400 million years. Their extraordinary resilience comes from their decentralized nature. They don't depend on unique vital organs that can fail, but are distributed networks capable of regeneration from microscopic fragments. Have you ever genuinely marveled at the incredible diversity of shapes, colors, textures, and sizes that mushrooms can assume? From microscopic fungi, almost invisible, that require magnification to be observed, to gigantic mushrooms that can grow larger than dinner tables, the fungal kingdom is a perpetual carnival of biological creativity, evolutionary innovation, and natural artistic experimentation. Walk through any temperate forest in autumn, and you'll be greeted by a visual festival of fungi. Bright red mushrooms with white spots like something from fairy tales. Delicate oyster fungi growing in elegant layers on dead trunks. Bioluminescent mushrooms that glow with ghostly green-blue light and darkness. Species with shapes that defy imagination, some resembling corals, others like sponges, some like delicate cups, others like complex lace networks. But the true extraordinary diversity of fungi goes infinitely beyond what our limited eyes can perceive on the surface. Conservative mycologist scientists estimate that there are between 2.2 and 3.8 million distinct fungal species on Earth. That's approximately 5 times more than all known plants combined. And remember the humbling perspective. We know and have scientifically cataloged only a small fraction of these species, perhaps 5% of the total. Each individual fungal species is like a unique and irreplaceable book in life's cosmic library, containing evolutionary secrets, biochemical adaptations, and survival strategies accumulated and refined over millions of years of natural experimentation. Some fungi have dramatically specialized in living in extreme environments that would instantly kill most other life forms. In the abyssal depths of oceans where pressure would crush submarines, in scalding deserts where temperatures melt metal, in Arctic glaciers where life seems impossible, in acidic hot springs that would dissolve human tissues. Other fungi have developed life strategies so specific and specialized that they depend on just a single species of plant or animal for their survival. It's as if they were artists who chose to work exclusively with a single pigment, or musicians who compose only for one specific instrument, achieving perfection through extreme specialization. Did you know there are fungi that can literally control and manipulate insect minds like biological marionettes? Ophiocordyceps unilateralis infects specific ants and gradually takes control of their nervous systems, essentially turning them into obedient zombies. The fungus forces infected ants to abandon their safe colonies, methodically climb high branches or leaves, and position themselves in specific locations with ideal temperature and humidity before dying, creating perfect launching platforms to spread spores to infect more ants. It's like science fiction horror, but it happens routinely every day in tropical forests around the world. Other fungi have developed even more impressive and bizarre strategies. Some glow in darkness like living biological lanterns, creating ethereal green-blue light through biochemical reactions that save energy with incomparable efficiency compared to human lighting. Others can instantly change color when touched or injured, like microscopic chameleons responding to threats. Some produce audible sounds when growing, others release fragrances that can be detected kilometers away. There's an aquatic fungal species that can literally swim through water using flagella like small biological motors. Others can survive direct exposure to the vacuum of outer space, withstanding cosmic radiation that would be fatal to humans. Some fungi can live for thousands of years as individual organisms, others complete entire life cycles in a matter of hours. Fungi's morphological diversity is equally impressive. Some form networks of filaments so thin they're essentially invisible. Others create complex architectural structures that would rival Gothic cathedrals in elegance and engineering. Some are microscopic unicellular organisms. Others form the largest known living organisms on Earth, extending across thousands of underground hectares. This extraordinary diversity of fungi is absolutely fundamental to terrestrial ecosystem stability and resilience. Each species plays unique and irreplaceable roles like different instruments in a cosmic symphonic orchestra. When we lose fungal species through industrial pollution, climate change, habitat destruction, or destructive agricultural practices, it's as if we were removing vital instruments from the universal orchestra. Life's music becomes dramatically poorer, less resilient, less capable of responding harmoniously to environmental changes. Have you ever wondered how many revolutionary solutions to humanity's most urgent problems might be hidden in fungi's still unexplored diversity? Perhaps there's a species that can efficiently clean plastic-polluted oceans, another that can produce clean and renewable fuel, yet another that contains compounds capable of reversing aging processes or curing neurological diseases. The possibilities are literally unlimited when we contemplate the vastness of what we still don't know. Imagine a majestic forest devastated by a catastrophic wildfire. The post-fire scene is absolutely desolating. Century-old trees reduced to charred skeletons, soil covered by a thick layer of ash and charcoal, an almost absolute and heavy silence where there was once a rich symphony of abundant life. For most human observers, this would be the tragic end of the story, a final chapter of destruction and death. But fungi possess a radically different perspective on tragedy and renewal. They see extraordinary opportunity where others see only destruction and despair. In the days immediately following the devastating fire, when ashes are still settling and the air remains charged with smoke, fungi are already silently working on the regeneration process. They're microscopic spores which survive the fire's extreme temperatures by sleeping deeply in protected soil layers, begin to germinate like seeds of hope sprouting amid apparent devastation. Like specialized first responders arriving at a disaster scene, they immediately begin their essential work of stabilization and healing. Have you ever personally witnessed nature's incredible capacity for regeneration and renewal after a catastrophe? Fungi are literally the specialized first responders of wounded and traumatized ecosystems. They immediately begin stabilizing burnt and loose soil, preventing catastrophic erosion, and patiently recycling nutrients from dead plants, transforming destruction into fertility. It's as if they were highly trained emergency physicians of Earth, rushing to heal the planet's deep wounds with efficiency and wisdom accumulated over hundreds of millions of years of experience in natural disaster recovery. This extraordinary resilience of fungi offers a powerful and inspiring lesson for us humans, who often feel overwhelmed by personal or collective adversities. They teach us that even in the most desperate and apparently hopeless situations, life always finds creative ways to persist, adapt, and eventually thrive. That devastation can be transformed into the beginning of something new and possibly better, not necessarily the definitive end of everything. In urban environments severely polluted by decades of industrial activity, some fungi demonstrate almost miraculous environmental bioremediation capabilities. They can selectively absorb toxic heavy metals from contaminated soil, decompose complex chemical pollutants into harmless compounds, neutralize dangerous radioactive substances, and even process spilled petroleum into usable nutrients. It's as if they were microscopic environmental superheroes, working tirelessly to silently clean up the toxic mess we humans often create. One of modern mycology's most surprising discoveries was finding fungi. literally growing and thriving on the highly radioactive walls of the destroyed Chernobyl nuclear reactor. These extraordinary fungi developed the ability to use ionizing radiation as an energy source through a biochemical process similar to photosynthesis, but substituting sunlight with radiation. Where we see an uninhabitable dead zone, they found an innovative way to prosper and multiply. This isn't just impressive survival, it's creative transformation of extreme adversity into growth opportunity. Fungi's remarkable resilience isn't just individual, but fundamentally collective and community-based. When a specific fungal species is harmed or eliminated from an ecosystem, other related species quickly occupy its ecological niche, maintaining the system's vital functioning without significant interruption. It's like a professional substitute team always ready to enter the field when main players are injured. Different fungal species also actively collaborate during environmental recovery processes. Some species specialize in initial colonization of disturbed areas, others in decomposition of specific debris, still others in establishing partnerships with pioneer plants. It's an orchestrated ecological succession where each species plays its role at the appropriate moment. Fungi teach us that true resilience doesn't come from rigid resistance to change, but from adaptive flexibility and capacity for creative transformation. They don't fight against destructive forces, they embrace them and find ways to convert them into growth and renewal opportunities. This wisdom has profound applications for human societies facing climate, economic, or social crises. Instead of rigidly resisting change, perhaps we can learn from fungi to embrace transformation as an opportunity to create more resilient and sustainable systems. Let's now explore one of fungi's most fascinating and philosophically profound characteristics, their extraordinary capacity to connect worlds and realities that appear separate and independent. Imagine you're exploring an exuberant tropical forest, observing a delicate and colorful orchid hanging gracefully from the high branch of a massive tree. This ethereal orchid seems to be living magically in pure air, without visible contact with the nutritious soil far below. How does it manage to survive and thrive in this seemingly impossible situation? The answer lies in highly specialized mycorrhizal fungi that live symbiotically in its delicate aerial roots. These extraordinary fungi form invisible molecular bridges between the suspended orchid and the host tree, and between the tree and the rich forest soil dozens of meters below. It's like an elaborate three-dimensional public transportation system, transporting vital water and essential nutrients up-down, and laterally through the forest's complex vertical architecture. Have you ever paused to deeply contemplate how worlds apparently separate and isolated are, in reality, profoundly and intimately connected through invisible networks of cooperation and mutual exchange? Fungi reveal to us a fundamental truth about the nature of reality. There are no true islands of isolation in nature. Absolutely everything is connected through invisible webs of interdependence and reciprocity. This extraordinary capacity for connection extends far beyond plant relationships. Some fungi establish complex symbiotic partnerships with photosynthetic algae, creating completely new composite organisms called lichens, hybrid entities that combine the capabilities of two different biological kingdoms to colonize environments that would be impossible for either partner individually. It's as if two artists from completely different cultural traditions decided to collaborate to create a totally new and revolutionary art form that transcends the limitations of both original traditions. The resulting lichens are extraordinary environmental pioneers, capable of surviving and thriving in extreme environments where neither plants nor fungi could live independently. Arid rocky surfaces, exposed tree bark, the frozen vastness of Antarctica, scalding deserts, high-altitude environments with intense UV radiation. They grow with extraordinary patience, often only a few millimeters per year, but can live for thousands of years, accumulating environmental wisdom over periods spanning entire human civilizations. They're like living, breathing libraries, continuously archiving detailed information about climate changes, air quality, atmospheric pollution, and environmental transformations over centuries or millennia. Scientists study ancient lichens to reconstruct regional climate histories with precision comparable to tree rings or ice cores. Other fungi serve as fundamental connectors between the world of the living and the world of the dead. facilitating continuous transformation between these apparently opposite realities. They are the only organisms on Earth capable of efficiently decomposing lignin, the complex polymer that gives structural rigidity to wood. Without this unique fungal capability, world forests would quickly become cluttered with trunks and dead branches that never decompose, creating massive accumulations of inaccessible organic matter. It's as if fungi were specialized and highly qualified translators, uniquely capable of reading and interpreting death's complex chemical language to fluently convert it back into the universal language of renewed life. This unique connecting capacity of fungi has inspired visionary scientists and biomimetic engineers to develop completely new materials and technologies based on fungal principles. Imagine building sustainable houses using bricks cultivated from mycelium, structures that grow naturally instead of being manufactured, or creating commercial packaging that automatically decomposes into plant nutrients after use. Researchers are experimenting with biological computers, based on mycelial networks that can process information and solve complex problems similarly to nervous systems. Others are developing construction materials that can literally heal themselves when damaged, inspired by fungi's regenerative capacity. Fungi are teaching us to reconnect human technology with natural systems in ways previously considered impossible or fantastical. They show us that the boundary between organic and technological, between natural and artificial, is much more fluid and permeable than our industrialized culture traditionally imagined. Perhaps more profoundly, fungi invite us to reconsider our understanding of where one organism ends and another begins. In complex mycorrhizal networks, it's often impossible to determine where the fungus ends and partner plants begin. They exist as hybrid entities, superorganisms that transcend traditional biological categories. This perspective has revolutionary implications for how we understand identity, individuality, and autonomy. Perhaps we humans are also much more interconnected and interdependent than our individualistic culture recognizes. Perhaps true wisdom comes from recognizing and celebrating our fundamental connections with all other living beings. Have you ever paused to seriously contemplate the profoundly different relationship that various life forms maintain with time and duration? We humans live approximately 70 to 80 years and already consider that a substantial and well-lived life. But fungi operate on temporal scales that completely challenge our limited human understanding of longevity and persistence. Imagine an individual organism that has been growing continuously for more than 2,400 years, methodically spreading across more than 900 hectares, an area vaster than 1,200 standard soccer fields. This is Armillaria ostoi, discovered in Oregon forests, United States, officially considered the largest and possibly oldest individual living organism known on Earth. You could probably walk over it for hours without ever realizing you're stepping on a single colossal living being. How can an organism exist and thrive for such incomprehensibly long periods? The answer lies in the radically different way fungi experience and organize temporal existence. They don't possess a single vulnerable command center like our brain or heart. Instead, they are distributed and resilient networks, capable of completely dying in one region while continuing to grow vigorously in other areas. It's as if they were immortal through perpetual regeneration and risk distribution. This unique temporal perspective gives fungi a special form of accumulated environmental wisdom. They are silent witnesses to gradual climate changes, mass extinctions, the slow rise and eventual fall of entire forests, geological changes, animal population fluctuations over hundreds or thousands of years. In their microscopic filaments is archived a living library of ecological experiences, spanning millennia of terrestrial history. Have you ever wondered what it really means to intimately know a specific place? Fungi know their forest soils in a way that we, with our brief and mobile lives, can barely begin to comprehend. They have patiently explored every grain of earth, every microcavity, every nutrient source, every seasonal change, every moisture fluctuation. They know environmental alterations like we know our familiar daily routine. During their millennia of existence, these ancestral fungi have witnessed the arrival and departure of countless animal generations. They saw mammoths walking over them during the Ice Age, watched the first humans exploring virgin forests, observed agriculture's development were silent witnesses to the Industrial Revolution. Their temporal perspective completely transcends the scale of human history. But fungi also teach us valuable lessons about extraordinary patience and perfect timing. A microscopic fungal spore can remain completely dormant for decades or even centuries, patiently waiting for the exact environmental conditions to germinate. It's like a seed of pure possibility, waiting with infinite patience for the cosmically perfect moment to express itself and flourish. Some spores have been found viable and capable of germination, after hundreds of years of dormancy in seemingly impossible conditions. This capacity to completely suspend active life and wait for future opportunities is a temporal strategy that our human culture obsessed with instant gratification could study profitably. This special and sophisticated relationship with time makes fungi valuable natural chroniclers of long-term environmental changes. Paleoclimatologist scientists study fossilized fungi preserved in ancient ice layers or lacustrine sediments to understand how Earth's climate changed over tens of thousands of years. It's like reading carefully preserved pages from a cosmic diary written by fungi themselves through their biological responses to environmental conditions. Fungi teach us that there is profound wisdom in operating on temporal scales that transcend individual perspectives. Their decisions and adaptations are informed by experiences accumulated over thousands of years, a perspective that could revolutionize how we approach long-term human problems like climate change, resource conservation, and social sustainability. Imagine if our species could develop the capacity to make decisions based on thousand-year perspectives instead of few-year electoral cycles. Fungi show us that longevity and wisdom come not from resisting change, but from developing sufficient flexibility to gracefully adapt to inevitable transformations. They also teach us about continuity through discontinuity. Although individual parts of a fungus may die, the larger network persists and regenerates. It's a form of collective immortality that transcends individual survival, a powerful lesson for human civilizations aspiring to lasting legacies. As our contemplative journey through fungi's invisible realms gradually approaches its end, I invite you to pause and deeply reflect on all the transformative lessons these extraordinary beings have offered us throughout this night of discovery. They are silent and humble teachers, but their lessons are profoundly wise, fundamentally transformative, and infinitely applicable to our modern human lives. The first fundamental lesson is about genuine cooperation versus destructive competition. In a world where we're often conditioned to believe that personal success necessarily comes from ruthless competition and domination over others, fungi patiently and consistently show us that evolution's and ecology's greatest achievements arise from sophisticated collaboration and generous reciprocity. They don't brutally dominate other organisms, they support, nurture, and strengthen them. They don't conquer territories through violence, they connect communities through networks of mutual support. The second profound lesson is about creative transformation and perpetual renewal. Fungi teach us that absolutely nothing is truly irreversible waste in nature's economy, that every apparent ending is simultaneously a potential new beginning. They possess the alchemical vision to see extraordinary possibilities where we see only unsolvable problems, growth opportunities where we see only insurmountable obstacles. They are masters in the art of transforming adversity into advantage, limitations into innovations. The third essential lesson is about authentic humility and power through chosen invisibility. Despite being absolutely fundamental to life's continuation on Earth, fungi rarely seek public recognition or applause. They work tirelessly in ecosystem backstages, without fanfare, without ego, without need for credit or gratitude. Their true power lies precisely in their invisibility, their profound influence in their subtlety and modesty. Have you ever seriously considered how radically different our human society would be if we consistently applied these fundamental fungal lessons in our personal lives, social relations, and political structures? Imagine human communities organized like organic mycelial networks, where one individual's genuine success automatically contributes to everyone's collective success, where the most experienced and well-established naturally nurture the youngest and most vulnerable without expectation, where resources are fluidly shared based on real need, not accumulation capacity or purchasing power. Fungi also teach us valuable lessons about authentic resilience and creative adaptability in the face of inevitable changes. They don't rigidly resist environmental transformations. They embrace them with curiosity and find innovative ways to thrive within new conditions. They are evolutionary masters at transforming apparent limitations into advantageous specializations, crises into exponential growth opportunities. Perhaps fungi's most humbling and simultaneously liberating lesson is about our own relative cosmic insignificance and, paradoxically, our profound and inescapable interconnection with all other living beings. We humans are almost infantile newcomers to this ancient planet. Fungi were established here billions of years before our species even existed, and will probably remain prospering long after our civilization transforms into something unrecognizable or disappears completely. But while we're here temporarily inhabiting this planet we share, we are integral parts of their life networks, completely dependent on their invisible work, intrinsically connected to their accumulated ancestral wisdom. This perspective simultaneously diminishes our species-specific ego and expands our identification to include life's broader terrestrial community. Fungi invite us to dramatically expand our limited definition of intelligence and consciousness. They don't possess centralized brains as we know and value them, but demonstrate extraordinarily sophisticated forms of information processing, collective decision-making, creative problem-solving, and even behaviors that seem to indicate memory and learning. They fundamentally challenge us to reconsider what it really means to be intelligent, conscious, or wise in the universe. Perhaps consciousness isn't an exclusive property of organisms with centralized nervous systems and compact brains, but a natural emergent quality of complex and interconnected networks operating on multiple scales. If this insight is true, then the vast mycelial networks extending for kilometers through forest soils may represent forms of collective consciousness and information processing that we're barely beginning to understand or appreciate. This possibility invites us to radical and transformative humility regarding our position in the cosmos. If fungi can be conscious in ways our science doesn't yet adequately understand, what other forms of consciousness might exist constantly around us, operating on temporal and spatial scales that make their intelligence virtually invisible to our limited and anthropocentric perception? How should this possibility profoundly influence the way we treat the natural world? How we make decisions affecting entire ecosystems, how we define progress and development in relation to the rest of terrestrial life's community? Fungi also teach us about extraordinary patience and unshakable persistence. A mycelium can grow steadily for decades toward a distant nutrient source, never giving up, always finding creative paths around apparently insurmountable obstacles, maintaining its general direction even when forced to make significant temporary detours. It's a powerful lesson about intelligent perseverance and deep faith in life's fundamental process. In a human world where we expect instant results and become frustrated with any delay, fungi patiently remind us that the most profound and lasting transformations happen gradually, imperceptibly, but inevitably. That planting a seed of idea or intention today can result in a forest of possibilities decades from now, sustained by invisible networks of connection and support that will connect future generations. Tonight, as you prepare to transition to sleep and dreams, carry with you the inspiring image of the vast, invisible network that continuously sustains all life on Earth. Know with certainty that you are an integral part of this ancestral network, that your breathing, your steps, your own physical existence is intimately intertwined with fungi's silent and generous work. And when you wake tomorrow to a new day, perhaps you can see the world through slightly different and wiser eyes. Perhaps you can begin to perceive the invisible but real connections that fundamentally unite us with all other life forms. Perhaps you can feel genuine gratitude for the invisible guardians who work tirelessly to keep our planet habitable, breathable, and nutritious for all creatures. Fungi leave us with a profound final question, a question that echoes through billions of years of their patient existence, a question that invites us to radically rethink our relationship with life. If we scientifically know only about 5% of all fungal species that actually exist on Earth, and if these mere 5% known have already completely revolutionized our understanding of life and provided us with medicines that save millions of human lives annually, what incredible secrets, what transformative solutions, what unimaginable wisdom might be hidden in the 95% still completely unknown to our science. And even more profoundly, if fungi, in their ancestral evolutionary wisdom of hundreds of millions of years, managed to create and maintain systems of perfect sustainability, efficient communication, automatic regeneration, and adaptive resilience that have worked harmoniously for billions of years without significant failures, what fundamental lessons do we still urgently need? To learn to create a future where humanity can prosper in genuine harmony with the rest of life on Earth? And so we gently arrive at the end of our contemplative journey through fungi's invisible realms, these silent guardians of terrestrial life. But have we really reached a definitive end, or have we merely begun to glimpse the oceanic depths of mystery that constantly surrounds us? Do you remember when we began this exploration? When I invited you to imagine yourself magically shrinking to ant size to explore the rich soil beneath your feet? Now, I sincerely hope you've developed a completely new and transformed perspective on the world you step on every day without thinking. Every step you take is literally over an entire universe of microscopic connections. Every breath you take is possible thanks to the tireless work of these invisible guardians operating 24 hours a day. When you wake tomorrow and look out the window at the outside world, you'll see trees with completely new and wiser eyes. You'll know with certainty that they're not alone in their struggle for survival, but deeply connected in an ancestral network of chemical communication, mutual support, and generous reciprocity. When you observe scattered fallen leaves on the ground, you won't see natural litter or inconvenient disorder, but you'll recognize the promising beginning of a new life cycle, orchestrated by nature's microscopic alchemists. Fungi offer us a radically different and transformative vision of what it really means to be alive on this unique planet. They patiently show us that life isn't a desperate solitary battle for individual survival, but an elegant collaborative dance of universal interdependence. That true strength doesn't come from brutal domination over others, but from generous connection and mutual support. That authentic wisdom isn't about controlling and exploiting nature, but about humbly learning from it and harmoniously integrating with its systems. At a crucial moment in human history when we face unprecedented environmental challenges, climate change, mass extinction, widespread pollution, soil degradation, fungi emerge as unlikely but absolutely essential mentors. They teach us about genuine sustainability, not just using fewer resources, but creating systems that naturally and indefinitely regenerate themselves. About real circular economy, where absolutely nothing is wasted and everything is continuously transformed into nutrients for new life. About authentic resilience, the capacity not just to passively survive changes, but to actively thrive through them. Have you ever seriously imagined that solutions to many of humanity's most urgent problems might be literally hidden under our feet, waiting for discovery? That perhaps we need to stop looking exclusively to distant stars for technological answers and begin paying reverent attention to the soil that sustains our daily existence? The science of fungi mycology is still in its relative infancy. Each new study reveals marvels that fundamentally challenge our limited understanding of life, consciousness, and intelligence. We're discovering fungi that can process information similarly to distributed biological computers, others that can solve extremely complex spatial navigation problems, some that seem to exhibit primitive but real forms of episodic memory and adaptive learning. These discoveries aren't merely fascinating but ultimately irrelevant. Scientific curiosities, they're actively revolutionizing applied fields like industrial biotechnology, personalized medicine, regenerative agriculture, material science, and even computational biology. We're learning to grow sustainable construction materials using cultivated mycelia, use specialized fungi to efficiently clean soils and waters contaminated by decades of industrial pollution, develop completely new medicines based on previously unknown fungal compounds. But perhaps the most valuable gift fungi offer US is a completely new way of thinking about ourselves and our place in the cosmos. They humbly remind us that we are part of something infinitely greater than our brief individual lives, temporary participants in a cosmic symphony that began billions of years before we were born and will continue majestically long after we depart. This perspective is simultaneously humbling and profoundly liberating. Humbling because it shows us how small and temporary we are in life's great universal tapestry. Liberating because it reveals that we're never truly alone or isolated, that we're constantly supported by an invisible but real network of life that works continuously to sustain our existence. Fungi also teach us about the transformative power of chosen invisibility. In a culture globally obsessed with celebrity, self-promotion, and constant visibility, they show us that the most important and lasting work often happens quietly backstage, without recognition or fanfare. That real positive influence doesn't come from dramatic appearing, but from genuine connecting. Not from individual shining, but from collective nurturing. Imagine for a moment how different it would be if each of us could incorporate a bit of ancestral fungal wisdom into our daily lives. If we could see beyond our immediate individual interests to clearly perceive how our individual well-being is intrinsically interconnected with all other beings' well-being. If we could value collaboration as much as competition, sustainability as much as economic growth, wisdom as much as information, fungi invite us to dramatically expand our narrow definition of intelligence and consciousness. They don't have brains as we know and privilege them, but demonstrate sophisticated forms of information processing, collective decision-making, creative problem-solving. They fundamentally challenge our assumptions about what it means to be intelligent and conscious in the universe. Perhaps consciousness isn't an exclusive property of organisms with central nervous systems, but an emergent quality of complex networks operating on multiple scales. If so, then the vast mycelial networks extending for kilometers through forest soils may represent forms of consciousness we're barely beginning to understand or appreciate. This possibility invites us to radical humility. If fungi can be conscious in ways we don't understand, what other forms of consciousness might exist around us, invisible to our limited perception? How should this influence how we treat the natural world? Fungi also teach about extraordinary patience and persistence. A mycelium can grow for decades toward a distant nutrient source, never giving up, always finding ways around obstacles. It's a powerful lesson about perseverance and faith in life's process. In a world where we expect instant results, fungi remind us that the most profound transformations happen slowly, imperceptibly, but inevitably. That planting a seed today can result in a forest 100 years from now, sustained by fungal networks that will connect plant generations. Tonight, as you prepare for sleep, carry with you the image of the invisible network that sustains all life on Earth. Know that you're part of this network, that your breathing, your steps, your own existence is intertwined with fungi's silent work. And when you wake tomorrow, perhaps you can see the world with slightly different eyes? Perhaps you can perceive the invisible connections that unite us with all other life forms. Perhaps you can feel gratitude for the invisible guardians who work tirelessly to keep our planet habitable. Fungi leave us with a final question, a question that echoes through billions of years of their existence, a question that invites us to rethink our relationship with life. If we know only 5% of all fungal species that exist on Earth, and if these 5% have already revolutionized our understanding of life and provided medicines that save millions of lives, what incredible secrets might be hidden in the still unknown 95%? And more profoundly still, if fungi in their ancestral wisdom managed to create systems of sustainability, communication, and regeneration that have functioned perfectly for billions of years, what lessons do we still need to learn to create a future where humanity can thrive in harmony with the rest of life on Earth? This is my farewell to you on this tranquil night. Thank you for accompanying me on this journey through the invisible realms of Earth's guardians. May fungi continue to inspire in you a reverence for life's complexity and beauty, humility before mysteries we don't yet understand, and determination to protect and honor the sacred network that sustains us all. Sleep well, knowing that while you rest, billions of fungi continue their silent work, recycling, connecting, nurturing, and regenerating the world so you can wake tomorrow on a planet even more alive and vibrant. With each breath you take while sleeping, remember that this breath is possible thanks to fungi's work that purifies air, creates soil, supports plants that produce oxygen. You are literally breathing a gift from the invisible guardians. And when morning comes, when you step outside and feel earth under your feet, remember that you're walking over one of the most sophisticated networks of communication and cooperation that ever existed. You are part of this network. You are supported by it. You are connected through it to every other living being on the planet. Fungi whisper a final truth through the ages, that separation is an illusion, that connection is reality, that life is a gift shared by all beings, sustained by the invisible generosity of those who work without recognition for the benefit of all. Take this truth into your dreams. Let it transform how you see the world. Let it guide how you live your life. Because when we truly understand our connection through life's fungal networks, we cannot help but live with more compassion, more wisdom, more gratitude for the miracle of shared existence. Dream well, dear listener, and may your dreams be filled with visions of the vast invisible networks of love and support that hold us all.